Hello, all present on data wrangling with dplyr is part 3. So this presentation, I will focus primarily on creating variables from free text and unstructured data. So a presentation is published in my address at Habtam Buzayo. You can also get a presentation in that is Analytics Hub. In this presentation, we'll see that means extracting words, extracting text into different, for example, if we have a text like 3 or 4 lengths, then how can we make 3 or 4 variables of that? And we'll see the other one is, so I'll go by step with processes to do a proper extraction out of free text and unstructured data, as the description about what is the importance of extracting free text. Free text is usually clinical data or in any data. There are free texts and one into a usable format is important. So we'll see one, and all this presentation, as previously noted, is available online in my GitHub. So you can go and have a look at this. So let's go then the example is when we have free text data, it's really important to understand what the data structure looks like, and also how can we better manipulate the data, understand, and to utilize in our. So for example, in this in this presentation, I'm planning to demonstrate many words into different parts. That means creating variables based on a single variable, that means 3 or 4 words. For example, in this data, I want to extract a birthplace, different formats. So before doing the extraction, it is very important to do step by step how the data structure looks like, they measured, and how the presentation, and also see how the pattern of the variables and the texts are in our data. So when one of the things that we determine, example, how many spaces are used to separate. Example, in this specific example, I have a birthplace and I want to separate that birthplace into city, state, and country. So maybe I'll open and show you what I want. So for example, in birthplace here, I have birthplace somewhere. Yes, this is a birthplace. So when we see the birthplace here, is Boston, Manchester, US, is Manchester, US, there is Lyon, Manchester, US. There are a lot of different ways of. So aim is the first letter or word represents the birthplace, the second one represents the state, and the last one represents the country. So I want to extract this data into country, that means region, and local birthplace. So to achieve this one, I want to understand how these variables are measured, what is the space between them, because I have to extract the variables, the texts from here to make a variable, a new. So achieving, it's very important to understand how the data and the structure looks like. All the descriptions are presented here. So for example, structure review is very important to visualize spaces between and extract or plus extract the spaces in the sequence. That means if you have then, for example, if you have 2 space or 1 space between variables, then we can have an extraction of the variables. So let us see example this one. So when we see this for Boston, Manchester, and US, it looks like there are 2 variables space. There is 1 space, there is 1 space and 2 space. There is here also similarly 1 space and 2 space. So it looks like there are 2 space between that means this is the birthplace, this is the state, and this is the country. But there are also long names. For example, most of them have 3 words, but the others have, for example, 4 or 5 words. For example, when we see this, it is 1 space here, as we see. This is 2 space. That means you can see how they are wide, and they are 2 space. So, for example, East Plymouth is, for example, a birthplace. That means a local name. and Manchester is the state name and US is the state name. So this is one of the things is really important to understand in text extraction. The other is to understand what is the sequence of space between words. So for example, this one is just give us a comma. Technically in R it tells us is a space comma in words, but maybe there is another one which gives a better. When we see, for example, when we count the number of spaces here, number of spaces, let's expand a bit. So we see the number of spaces, have 2 spaces 84. There are also 3 spaces for 15 variables. There are also 4 spaces for 4 variables, and there are 4 spaces for variables. So, I mean, in this case, what this does is for 3 and 4, need to do separate analysis to make with this first one. Let's go 1. So this gives a number of, and this one also gives a similar that are with 6. That means 1 space, there are 384 with 1 space, and there are 2 with spaces. So this is how data like. The other one, it is also very important, gives more option and flexibility, understand how the space looks like. That means using just this slash. So 1, 6. For the first name between this one, this 1, 1. This one is technically one name. So up to 1 is one name. That means 1 space, 1 space, 1 space, and then 2 spaces. There are also like similarly this one also have here and 1 space here and 1 space here and then 2. I think there are also a different, for example, this one have 2 here between parish and parish, it is 1 space. So John Parish is so we have 2, 1, 1, 2. So St. John Parish is a state name. Technically, we have only 1 space, but we have 2 spaces here. We understand from those who have 1 space are one name. That means it may be name, or it may be state name, or it may be local area name. So those who have 1 space are country name or local name or year. But between, for example, local area and state, there is 2 spaces. Between state and country, there are spaces. So to understand how our data is really structured. So from this observation, the data split birthplace by 2 spaces would be more appropriate. That means those 2 words having 1 space are the names for city, state, and country. So that means data we have understand that. Also, just for information, the data has been arranged in descending order. So the one we observed is how patterns, different patterns. So technically comfortable how the data presented, then possible to use space as one category name. It may be local name, it may be state, or it may be country name. So we are happy with number of characters. Then the next step is using a categorical data. That means we want to split birthplace into city, state, region, or country. That means we want to create 3 different variables, 1 text. So using a mutate variable and also using structure split, that means a splitting of the structure, I say split into by 2 spaces. So this is 2 is the space. If we say 1, so it will split all. If the space is between words is 3, we can say 3. Then city is map structure, character parts. That means part of the part is the one we say birthplace here. So from parts, then we can say first one is if we found, this is a conditional statement or function. If we found in parts in the city, can extract, otherwise we can say NA character. That means if, for example, if there is no name, we can say NA. If there is city name, we can say, well, that means the name of the first part. For the second part, that means the region or the state, we can assign 3 is the third part. Then after that, I will select birthplace city and country city. Let's here and what's happening. And also let's do the tail as well, so we can understand how the data works. So we see the top 10 observations. Now, for example, Boston, Manchester, and US. Now it's changed. The city is Boston, the state is Manchester, and the country is US. When we see the top lower parts, for example, Millis US is one is the city name, this one is a state name, and US is a country name. So now we can do data analysis by city, state, and country. So this presentation objective is from aggregated, we can create different variables by using a word space as an option to recategorize the variables or to extract or to split observations different. So for example, this is from DO, a country for DO. So it's extracted like San Diego and DO. So between this, it is one space, it is one space, it is one space. That's why it's extracted as a city name. And then this one is a name and the DO is a country name. So message here is, it's possible to extract, generate variables along text. And it's very important to understand the pattern of the space between. The next one, pattern analysis, a continuation of text pattern analysis in other formats. For example, if you have a free or unstructured text, then how can we address conditions? So that might be important, dealing or extracting text variables. So tokenization is breaking into parts. So for example, this one, I have vaccination data, and from this vaccination data, I want to see how the vaccination, how the description looks like. Maybe if I open the vaccination data, so this is the description as you see in this column. So it is really messy and are very long, and vaccination prescriptions, different name as create vaccination data of text unstructured data. So just let's do some step by step of the data, how it looks like and how can we better and extract out of here. So one is used to understand, example, breaking the within that means within this one there are, for example, one count sort measure, that means the word is also mapping them, understand how the words are. For example, we have influenza, we have seasonal. Of this, influenza is important, but others are not important because technically have like pediatric, adolescent, something like that. These are the words that will be extracted. So they are extracted, then the next step is understanding the texts and are described. The other is removal. The stop word one is one, for example, or something like that. So this is really important to remove those words and only focus on parts. So technically similar with the above one, but this is steps to understand how our text looks like. So word removal, that means stop words, is technically used to the word TD text. That means by removing the something like that adjectives or connectors, removing one. This is also using the frequent, and thus word is also doing some. So as we see here, ggplot our look like, for example, is the most popular word. Free is the most popular word, and the others are, for example, we can see COVID-19 here, we can see influenza, we can see tetanus, PCV, DTaP. So this is a good option to variables or how the texts, when we extract them, how they, so it gives understanding. So here the other is also using a word cloud. Word cloud is also a better option to understand what are our common words. For example, dose is a common word because technically when we prescribe vaccine, we use dose, something like that. So dose is of the word, hep is the other word, COVID is of the common word. 19 is actually, it is extracted COVID and 19, so 19 is coming as well. So IPV, toxoid, tetanus. So this us how, like, sort using word cloud or using plot the way we see the bar graph or the number of. These are the options to understand just doing data. It is very important to understand what are the texts, what are the common texts, and how they behave. The other is using bigrams and trigrams. Actually, if there are of words, triplets of words, for example, words or three connected words or connected words. So, for example, pre is one of the bivariates. That means seasonal is one of the injectable preservatives, also one of the things that's connected to words. And when we see trigrams, means words, three connected words or consecutive words. For example, influenza injectable preservative free. These are some of the preservative or three continuous words available in our text. So this gives us an image how our text looks like. Also, it's important to in the Word and also read, and also you can export this one as a CSV or Excel and understand how the words and the texts within this free text like. The above are some of the to explore our texts look like. So now go to generating a variable. So we use Regex, that means variables. And this one is, for example, if you have COVID or SARS, COVID-2, then we say COVID-19. If we have influenza, and we can say ignore case. That means, for example, it may be influenza S, or it may be, if there is a word influenza, it's example COVID. If you have COVID-19 or COVID/19, something like that, it accepts like it accepts as a COVID-19. So it's really important to understand here. For example, if you have Hep A or Hep B, then hepatitis, then it will extract, it will label as. So as the code, for example, for pneumonia, pneumococcal, we say pneumococcal 3, ignore pneumococcal. Is we need to understand data. Once we understand our data, how the free text looks like, the next step is, for example, using ignore case. That means in here, the message is, for example, if you have COVID-19 like this, or it might be COVID-19 like this, or it may be COVID-19 this. So all this are extracted by this word. By including this one, we can extract all these different forms of. I can now extract words. So hepatitis, I choose Hep A and Hep B, understanding my variables. For DPT, I use DPTA, TDAP, and there is adult as well, and use this one as well. So let's this variable, and now our created a clean and nice variable out of this text. This was the free text as you have looked previously. So from out of this free text, we have now created a very nice and clean. So if we see head at group, so we see our vaccination. This is the vaccine group. So we can see our different forms. So I've created a variable in a nice and clean one. So we can use we can also record this vaccine. For example, if we say respiratory vaccine or childhood vaccine using case when, as we discussed in the previous. And also you can see, example, influenza is respiratory vaccine. DPT is childhood vaccine. Technically, if we have influenza, COVID, I say respiratory vaccine. If there are hepatitis, Hep V, IPV, I say meningococcal or MMR, I say. And for others, I say other. This presentation, also all the examples presents are also presented here. You can have a look, you get time in my, so there are also detailed clarifications how each works and also extra, and you can have a look when you, and as I previously noted, you can get my, this presentation, GitHub, that means Hub Tumblr, or you can also access this presentation in my Analytics Hub in my YouTube. So much for I will see you the next is creating a categorical for now.